Now it seems to be working. Hey guys, welcome back to another episode of Simuleo. It's the only channel on Twitch that is home to the algorithm archive. I'm not really sure what my tagline should be here, but that's okay. Apologize for starting just a hair late. We ended up, okay, so you guys all saw it. Basically, I started the stream. The camera was all wonky, so I restarted the stream to fix it because I figured, hey, just wasting a minute here isn't that big of a deal. Okay, so the reason I think I had to restart the stream, Demoplause, is because every time there's a camera issue on my end, if I remove the camera object from OBS, it actually doesn't exist anymore, because for some reason I have to start OBS, which turns on the camera, then I have to start CAF Jack host, which is a host for the Jack audio system on Linux, and if I do it in the opposite order, the camera doesn't appear at all. So what ends up happening is it kind of captures the camera after starting up CAF Jack host, so I have to kind of start the camera first, then start that. It's kind of a weird situation, but it's the only way I can really get consistent audio coming from a microphone by using Linux, or it was as of a year and a half ago when I set it up. So it's a little bit of a weird setup. That's how it goes. The cat throws Demoplause, Buttercake. Thanks for coming in, guys. Okay, so what are we doing today? Well, let's go back to what we did yesterday. No, today, I'll be honest, I'm not sure if it's going to be a short episode or not. We're going to see how this goes. So I'm going to cd into projects, scivl. I go over here, cd projects, scivl. Now I'm going to run the last command that we did, scivl -s, and we're going to run Euclid. There we go. Okay. So what we're allowed to do here is we have two different methods to do our simulation here. We have the, what are they? The recursive method, which we didn't put in, the modular based method, which is this one right here. And then we also have the, I don't remember why it's S. Crap. Subtraction based method. There we go. And this kind of shows us the differences between the two algorithms. We need to make this a little bit cleaner, but for now what I want to do is add in some text down here. Change the clear command so it doesn't clear all the shapes, just the ones that are unnecessary, and then we can kind of go from there. So the first thing I need to do is just add some simple text right down here, and then I need to add in the ability to write text, which right now we don't currently have. So that's going to be a little bit interesting, and it could potentially not work, so we're going to see how this goes. I'm kind of dubious. I'm a little bit worried that I have no idea what I'm doing when it comes to this kind of stuff. So we'll see how it goes. It's going to be interesting regardless. Okay, so the first thing I want to do is go into VI source, distributions. Now, here's the thing. I went through last night, and there's this guy. It's like lazy foo, text input. Let's see, something like this. And I'm sure you'll have it. Hey, Cranigan, thanks for coming in. Text input and clipboard handling? Yeah, I think this is it. Okay, first of all, his website's really hard to read because of the color scheme. Black on blue is kind of hard on my eyes, but that's okay. So basically he went through and he was like, hey, SDL start text input, then render, render text input, and go from there. So what we need then is kind of like a method in order to start text input. Now, one thing I don't have right now is the ability to click my screen. So if I run Euclid, I don't have, my mouse doesn't mean anything. Ideally, I would have it so my mouse means something, but we'll get there one step at a time. You know, we haven't really added everything in yet. So let's go ahead and add in the text, because I think that's relatively straightforward, and then we'll go from there. So first thing I want to do is pop down here to the very bottom. And we have all of these lines that we're pushing back. Oh, that's the straight across line. So I'm going to go ahead and add in the text. So I'm going to say write text. And I think it's just par. And then the text I want to write at the location. So let me go and check that. VI source, shape functions, and let's look for write. I don't have it. Write string. Okay. Sample text, position, 1.0f. Oh, that's probably like the size or something like that. Great, okay, well I'm just going to grab this guy, because that's going to help. I'll just grab this guy. There we go, this is going to be great. Hey, happy little rat. Pop it down here. Oh, pop it here, and go here. Okay, so now what we have is a position and 20F, 20F. Well, that seems awfully far away. Let's just change it to 0, 0 for now. We have sample text. We're reading in the position, reading in the size, and we have a glmvec3 here, which I think stands for the color. Let's just see what happens when we make this and run it. Man, this is great for notational sake. Yes, position already appears, so let's do position of text. Seems like you're doing great with OGL these days. Yeah, great. Hey, that's your fan, what up? Oh, that was what I meant to do. Go over here, make that. And now we're gonna go to... yeah, okay, so to be fair, here, let me explain something real quick. So we just made it, let's run Euclid. Oh. I'm not really sure what happened there. Let's remove this real quick. Let's make that again. And yeah, open game license, there it is. It is the open graphics library, I guess. I'm not really sure. There's our line. Where was our line over here? Come on. DD. Oh, you know what? I think I know what might be the problem. Let me go up to write text. Sorry. Write string. Yeah, there and there. Yeah, it's in the function. Okay, let me pop down here and let me grab these guys. So D2D, and let me put it up in the, what is this called? This is called the Euclid function. Here. So let's see what happens if we paste it here. Go over here and make that. And let's see. Not even DirectX 12. Nope. Yeah, you don't exist. That's great. Where is it? Oh, let's try 20F again. Guess that's what the other one was, and I'm not really sure. Make. Yeah, Vulkan's super interesting. Where is the text? Why is this happening? Why is it all the way over there? Come on. I know write text works because... Or string, I guess. It's right here for the platformer. Oh, wait a minute. Pong. Sample text. Euclid function. Wait a minute. Let me check something. VI source, aux functions. Let's look for Fourier. Write string. Draw FFT, write string real. Position is equal to that. Yeah, okay, that seems okay. Let me look for draw FFT. Look, I know this function works. I'm like 90% sure works. No, I don't think I have a background layer here. Once I get this working, I'll explain something that I said I would explain just a second ago. Let me just try writing this real quick. So let me just string, and let's just pop it over here. Make. Was there something I was supposed to do that I forgot to do? I mean, that's obvious. There must be something. Make clean. Make. Yeah, that's probably the case. The function is probably working. I'm just screwing up. Okay. So there's a couple things I wanted to point out here. First of all, before using OpenGL, we had the ability to visualize our stuff with a CPU-bound rendering system known as Cairo. And Cairo worked very well. Don't get me wrong. I think some of the best visualizations we've done on this channel have been done with Cairo. However, these visualizations lack the ability to do things interactively, which meant that, you know, as I continued forward and made more and more visualizations, first of all, these visualizations were harder and harder to find because they weren't on some central library or some central application that people could use. And second of all, it was just harder and harder for people to figure out how to use it. So you'd run the simulation to generate a huge list of different images, and then we'd have to concatenate all the images into a video. In this case, it's already in a video, it's already easy to use. So what I wanted to do was, as I started making the Arcane algorithm archive better and better, I wanted to also work on making this, which is a scientific visualization library, better and better. So at some point, not only are the algorithms like very interesting and useful, and everyone enjoys reading the Arcane algorithm archive, but the videos too have a great graphical component to go with them. And that's kind of the idea. So I figured the better I get at one, the better I get at the other, and slowly but surely we build and build. I want it to be that like a year from now, we look back on what we're making now, and we just completely blow whatever we were making back then out of the water, you know? But that will only happen if we kind of attack this on multiple fronts. So that's kind of my idea here. So right now I understand that the visualizations may not be crazy good, but at the same time they suffice, and we're making it better and better, I hope, every simulation. So that's the hope. Okay, let me run and see what happens if I run this. The color, I'm not really sure what the deal is here. The color should be, oh, maybe there's something else I'm missing here. Let me go into the FFT stuff. The color should be this color right here. It's a GLM Vec 3 there. I'm really overusing the Vec 3s. Platformer key. Create quad. That's the thing I'm not doing here. Par.shapemap text. Text shader use. Yeah, okay. One second. Let me see what happens if we do this. And pop down here. Do I have the text shader? I do not. Yeah, okay, this would totally explain it. So what do we have here then? Shader defaults, let me just go to text and see what we have. Par.text. What do we have? One second. I have par.text, but I don't know what par.text is. Okay, well maybe it's okay. So let me just grab this guy. And let's pop down here. And let's use that shader for what we have. So GL enable, I think it's after these guys. Paste it here. And let me see what happens if we go here and make that. And then we do Euclid. Okay, well there's a line. I don't see the text, but we're getting there. I know the text exists because when we do SciVL simulation Fourier, we have text here. And this is kind of what I wanted to replicate, having the ability to generate text. So I think this is probably the best visualization we've done so far. I'm quite happy with it. On the other hand, it was the one that we spent the most time on. So, you know, slowly but surely our visualizations are getting better and they're taking less time to create. That's what we're doing here. Okay. So we have the text shader here. Let me see what else we did. So create quad. Here, par.text. Let me see, what is par.text? Okay, let's go into VI source. Right string there. I actually don't know. Draw shapes par.screen, platformer function. Actually, here's something. This string doesn't appear in our platformer. So I think I'm screwing something up. Where's our Fourier? We say font size. There. Hey Sarah, what's the problem? Part resolution, part start time, Fourier RGL. Text map. Resolution. Yeah, I really should have paid attention to this. Set up free type. What's the problem with math, man? Hey Roxtonro, how are you? Okay. So, I'm not exactly sure why the text isn't appearing. I thought this would take 2 seconds. I was incorrect about that assumption, as I am incorrect about just about every assumption. So, let's go through and let's see what we're doing here. So we have the text shader and stuff like this. Basically, the text is drawn in OpenGL by generating a bunch of what are known as quads. And so these are squares that are held behind the object, that are the appropriate shape for the object to be held in. So let me go to the right. Let's see, right string, all these guys work. Audio on the frets. Fair enough, VI source, and let's go into aux functions. And let's look for right string. Okay, so it looks like, to me, draw FFT literally just writes all the strings we need, and it doesn't seem to need anything else. So this means that when we go into the OpenGL function, the OpenGL function for start with the on. The OpenGL function for the FFT does work in generating text. So let's see what we have there and see what we're missing. Let's see, for OpenGL. I want to start writing optimization algorithms, etc. in C++, but I've never had proper math education. So I need to brush up on my linear algebra for, yeah, that kind of stuff. Assumption that something will get done in time allocated for it is mostly invalid. That's definitely true. Okay, good linear algebra books. I don't know the best linear algebra book for computer science. In fact, I really can't recommend any good linear algebra books, period, because the linear algebra class I took in high school was quite poor. But I think maybe someone in the chat might know a little bit better than I do. I'm sorry I can't help with this one so much, because, again, linear algebra was probably my worst course. So I feel like anything I would do or anything I'd say or recommend would not be the best one. But what I can do is I can ask my sister, who's a mathematician, and get back to you in a little bit. Okay, introduction to linear algebra, good. Online courses, good. Okay. Text. Let me go see what this par.text guy is. VI source, include GL setup, and let's do text. Texture, text, shape text. Oh, it's just a shape. Great. So let's see, we create the quad. Did I forget to push back something? Shape line, shape array, push back. Let's look for quad. Let's look for text. Box around the text. Text shader. No, that's for platformer. Dagnabbit. Is there any way for me to download the math into my brain? Oh, no, unfortunately not. I keep getting all these comments on my 4D video that I put out about something like this, about how they just don't understand it, yada yada. At some point, it's just you start understanding math like it's another language, and it helps out. But there's an issue with how do I put this? It's hard to just understand math. It's not something that just comes naturally. So I understand why people have trouble with it. It's hard because it's one of those things that you think is easy, and then when you try doing it, it just feels hard. Or it's one of those things that you think is hard, and when you start doing it, it is as hard as you think, you know? It's like programming in a way. I mean, a lot of people are scared of programming because they think it's too difficult, and then you get into it and you're like, yeah, okay, I can see how to do this and this and this. But then you look at people who are doing like huge applications, and they're just, it's next to impossible to think about how you can get to that point, you know? And I think it's very similar to math. Here's an algorithm, do nothing. Not much of an algorithm. Okay. Now the question is, why is the text not rendering? That's a good question. So let's see, we have the text shader. Yep, we have the text shader. Bar.shapeMat text should be okay. So we're adding text to the shape map, or we're adding the text shader to the shader map. Good. We're setting up free type, and then we're going from there. Okay, so we're creating quads on par.text. So let's pop down here. Let me make sure I have all that. Create quad par.text. Yep, looks good. Okay. Yep, now I'm out of ideas. I have no idea what to do. So that might be the end of what we're doing today. I can't figure it out. Let's do make one more time to see what happens. Euclid. Yeah, obviously it's not appearing. Okay, distribution says CPP. Pop down here. Let's see, what else do I need to do then? Euclid, font, square root. Euclid parameters. Yep, that should be okay. Par sample text. Position of text. Let's try putting this at 0, 0. Because I've got a feeling this is incorrect. Make that. Euclid. Oh, there it is. Sample text. Got it. Fantastic. Okay, then you should start with implementing Verlet and then continue with collisions math. Yeah, I was thinking about this. Yeah, Verlet is pretty good because it's there. The how do I put this? Okay, here's something I was thinking about the other day. So actually, in addition to something that Buttercake actually responded to on the Discord chat, one of the issues with the Arcane Algorithm Archive is this. So let me go here. So here's the GitHub repository for the Arcane Algorithm Archive. I think this is probably pretty good. I like that we have one centralized location. Now here's something that how do I put it? That Buttercake brought up. Let's go into I don't know. Let's go to computational physics. Where are we? And then verlet.md. Okay, here's the markdown file for this. If we go down to the code, we have a lot of code here. So if you want to find the C implementation, you have to go all the way down to the bottom here to find the C implementation. You see what I'm saying? So this is a situation where I kind of felt like we need a better way to contribute and stuff like this. And so what Buttercake said, and I think I actually agree with this, is we do C++, but it's actually a link to somewhere else where the code is. You know, another page which is somehow hidden, maybe, that shows you what the code is, or something like this. Something that allows you to, how do I put it? Something that allows us to go through this example code section without having to scroll so much, if that makes sense. So that way they can very easily tell if their language of choice is there and if they can contribute and such like that. Plus, it makes it so people have compilable code immediately ready for them to work with. The only thing is, I think from now on I will request that people in their header explain how to compile the code and run it. So that's a little bit important. If you can get GitHub as something like that. What is your Discord? My Discord is this one. Send me a message when you get on there and let me know to add you to the Simuleos chat. So it's a general Twitch programming Discord, but I have a separate channel in there, along with a few other pretty good streamers on Twitch. Okay, I don't know if you can do spoiler tag. Let me try spoiler. And let me do spoiler tag. And let's do markdown. And let's see. There probably is a way to do this that I just didn't know about. Yeah, I wanted like a spoiler box, I guess. It's okay. We'll figure it out. Why not just use the markdown to link to specific code versions that are available alongside the algorithms.md? Oh, that's what we were going to do. Rux Tonro. I thought that was my idea, or that was the idea that we kind of worked with Buttercake. So one thing, Buttercake said to have a separate directory for all the code. And I think that's okay. But I feel like I don't want two separate repositories for this, just because I feel like it's going to be too easy to get them out of sync. And when you update one, you're going to have to update the other anyway. So I kind of feel like it's okay to have one central directory. But what we were going to do is add an additional, how do I put it, an additional directory here specifically for code. So I'd be like, hey, this is the Verlet algorithm, here's the code for the Verlet algorithm, so on and so forth. And I think this is probably a pretty good way to do it. So I like that idea, and I think we're going to try it for this algorithm when we go through it and go from there. Okay, on the other hand, we have sample text. That's fantastic. Okay, so now let's move the sample text somewhere, and let's put it somewhere. So what we want is for it to be -1. Let's do -1 in Y. Why would you have to update the other? Well, what I'm saying is, like, let's say we add a language, like in the book I just placed a link, says go to example code, links to directory containing all the code. I see what you're saying. I kind of feel like I like having, well, here's what I was imagining. Let me just go to algorithm archive. Algorithm archive. Here is the Fourier transform one, which I'm definitely going to have to make a video on the Fourier transform stuff in a bit. I just haven't decided when and how. Yeah, that'll come. Okay, let's do relay integration, since this is the one that we did. And let's scroll down here. So what I want to do is just kind of like C++, click on C++, go to the link. Yeah, that's basically what I was imagining, Rux Tonro. But what Buttercake is saying, yeah, I wanted a list of available code in the book, so people could just click on C++ and go to the C++ implementation. I like that idea because it allows, users to immediately see as they're going through which languages the code has been written in. And also it gives everyone the ability to check the code out. Now, the disadvantage obviously is that they're going to have to open up a new tab for this kind of thing. Also, I'm thinking about kind of what we're going to do in the future about this book. My initial... So, yeah, thinking about what we're going to do in the future here, my initial idea was that people could kind of bind their own versions of the Arcane Algorithm Archive. So if they wanted the Arcane Algorithm Archive C++ version, they would write the C++ version. If they wanted the Arcane Algorithm Archive Fortran version, they would bind the Fortran version. So basically, it's the Arcane Algorithm Archive with all the example code in a particular language that they want, you know? And I think the thing is, my initial idea was that this would also go and change, let's say we go to tree traversal, all of these snippets of code, so that these snippets of code are written in that language, if that makes sense. However, I'm not sure if that's the best way to do it anymore. I think the best way to do it is come up with a good, concise way to write pseudocode, and then put the pseudocode in all of these chapters. And I think what we're doing right now is probably the best way to do it, and put the example code afterwards. Reason being that this is, first of all, easier for me to do, and something that I could do in my free time. And second of all, I think it's just... I think pseudocode has its uses. Sometimes you just get bogged down in the implementation details of like C++ or something like that, and when that happens, it's just, there's no way you're going to be able to get back from that. You know, you're going to be stuck figuring out what, you know, this is a simple example, but like, you know, let's say you're going down and you're just looking at this, and I don't know, maybe you'll get stuck at how Q is implemented or something like this, you know? Something that you shouldn't be particularly implemented in, but that's what happens. Usesthis.com, by the way. They basically feature a different member of open source community every month or two and find out what's in their stack. Oh, that's quite interesting. Audio producer, audio Mac podcaster, Mac researcher, scientist. Oh, neural network trainer, researcher. Oh, I see. Wait, click on her? Oh, interesting. Interesting. Yeah, this is quite cool. I like this. I'm a big fan of open source stuff, so this is kind of neat. Oh, she looks a lot like someone that works here, but then I looked at her again and I was like, oh, nope. Neat. Okay, cool. Art guy, no pattern. Okay, we gotta get stuff done. So what I want to write down is, let's see, how do I want to do this? I'm gonna say, I don't want too much text. So what we're gonna write is something like, Euclidean algorithm. Example. Here. And let's put it somewhere, I'm not really sure where. Make that just to check if this works. Okay, it's a little bit high and the color is off, so let's change the color to, let's see, what do we have here? I'm going to change the color to white or something like that, and I'm going to move these guys down to the next line. Okay, never mind. DD. What? Oh, caps lock is on. That explains it. There we go. Let's go down here. And let's change the color to white. What happened? Oh, I missed the text. 1 second. So let's do 1.0 F. 1. And then 1.0 F. There's a filmmaker who will only use new licensed software for post-production. Yeah, it's gonna be rough. Does all his video editing in Blender. I also do all my video editing in Blender. So let's pop this down to size of the text, which I think in this case is going to be, let's see. I actually don't know. So let's say minus 0.1. Like that. Euclid. Okay, I don't know why that's blue. It should be... Oh, that's because I need to put a 1 here. Okay, good. Euclidean algorithm example. So if we do S... Yeah, okay, fine. Fair enough. So now what we need to do is I'm going to create a separate function here. Vi source, shape function. Oh, I also want... let me write all the strings first. So let's go ahead and do yank to yank. And let's do paste down here. And what I want to do is put this at the bottom. So let's also change the position of the text. Yank, yank, paste. And let's change this to negative 1. So it's at the very bottom of the screen. Okay. And we're going to say press S subtraction based method, and then we're going to say M for modulus based method. Okay, so now we have the keys. Are there any good open source cameras? What do you mean by open source cameras? So let me do M and S, and let's see what happens. So let's go here and make that. 1.0 F, yep, that should be here. Make that. I got an error. Position text. That's because I defined position text twice. Make that. Make that. Okay. Then we're going to run SciVL Euclid. Okay, good. I might want to move that text up a little bit at the bottom there. Make it a little bit smaller. So let's do that real quick. So let's do minus 0.9. Sorry, this is going to be kind of me just messing around. Pertus.org. What did I miss? Sorry about that. Oh, this is quite neat. Huh. Huh, okay. Yeah, okay. I'm interested in this. I'll keep it up. Are there any good open source cameras out there? What do we have here? I think he does all his video editing in Blender. There's another reference, Camera Obscura, no one on that line. He uses GIMP and Inkscape for titles and graphics. That's reasonable, but video production was a pain a few years back, and things are slightly crashy nowadays. Are there any good open source cameras out there? Yes, so... as far as things being crashy nowadays, I think it's still true that things do crash a good bit, but it's not so bad. Okay, so now what I want to do is, let me see. We have a string there. Now I want a couple of other strings, so I'm going to do yank 3 yank, and I'm going to paste one here. And I'm going to do it again down here. Sorry about that. So I think I can just do yank 3 yank again, and paste it here. There we go. Okay, so now we want a couple of other guys, so we're going to say number 1. Number 1, and we're going to say this is there, and number 2. Okay. So number 1 and number 2, these guys are defined in the Euclid par, element 1 and element 2. So how do we do this? What I want to do is put an integer into a string. I don't think we can just add strings in C++. I don't remember. So adding strings C++, I always look this up. I always forget. String, let's see, append string object. Oh, okay. So then let's just try this. So let's do number 2, and let's do, oh, I have to change it to a string. So let's do how to change int to string, C++. Number to string, hello world. OB has saved many people. Wait, how did OBS save many people? OBS is a isn't a video production thing. It's a video streaming thing, you know? Let's see, chart into string I2A. I2A, string stream. Yeah, okay. So if we do I2A, let's try this. So I wanted to do I2A plus I2A. I'm probably missing this one. So let's do I2A par dot IMAP of number 2. What did I call it? Element 2. Here. And then we want to change this to a string. So I think the idea is we do string. Let's make that, see what happens. I think I2A is not found. Yeah, oh, string is not found. I2A. Okay, so where's I2A? Let's find that. C++. Not much, just getting the text working. That's all we're doing here. stdlib.h. Yeah, that's the one I want. Go here and let's do stdlib.h. stdlib.h. There we go, that's probably it. Go over here and make that. And then it's probably going to complain I2A was not declared in the scope. Wait 1 second. I2A was declared in that scope. stdio? I don't think that's the case. Oh, maybe it's std. No, wait, where is this? 1 second. Let me think. It's recording streaming tool. It's not post-production, but it's still video production. Yeah, it could be. I mean, I use OBS for this, right? Recording tool that's stable and lets you composite scenes and everything, and has nice GUI. Yeah, so to be fair, you could use FFmpeg if you wanted to do your streaming. I know some people have, and I've definitely seen some good videos made from this. So it's not like it's the only solution. And there are some advantages to using one over the other or something. But you're right. In the end, having the ability to put your camera and stuff on screen in a GUI way is something that a lot of people really want. So it's quite useful. Okay. So the question then is, why don't I have I2A? Is not defined in NCC and is not part of C++. Oh, maybe I should just use string stream? stdlib.h? Yeah, that's what I got. stdio. Oh, that was 0. Yeah, I2A is not defined. Okay, great. String was not declared in the scope. Maybe it has to be std string. Let's go down to string. Write string next. Std. Make that. Maybe it has to be std whatever. Std. Make that. Nah, still doesn't exist. Dagnabbit. stdio is a library for lead hack source. Yeah, pretty much. Okay, I have to figure out why this isn't existing. That's the only problem I have. I know I've used it before, but for some reason it's just not. It's not doing anything this time. It should just be stdlib.h. stdlib.h. That's what I've got. I2A. Let's see, what do we have here? DuckDuckGo has a lot of code references for many languages. Oh, interesting. I didn't know that. Dell is Soul Dead, what's up? Is this some science fiction memes? No. I'd help, but I have no idea, so I'll just keep making stupid jokes. That's okay, don't worry about it. That's generally what happens, so let's make this. Okay, so the problem this time is... Oh, something else. Make clean, make. See what happens. I learned to love DDG. Yes. Conversion from unordered map. Invalid conversion from SD unordered map to constant char permissive. No matching function call basic string. Let me clear. And let's try this again. Make. What do we have here? Looks like the error is this invalid conversion from unordered map here. So let's pop down here to I2A. I2A. The heck? Oh, I bet you I know. Yeah, it's probably... Yeah, okay, I removed I2A. So that's obviously the issue. Tried to lower my Google usage, so I've tried it and thought it was an inferior alternative. 2 days later, I didn't want to go back to Google. Oh, really? Interesting. So, I don't know, I'm hit and miss, but I might try it for a bit, see what happens. Okay, so now the question is, maybe we should have just done string stream. So if we have in a string stream SS, string is equal to SS dot. Let me see. Include string. Oh, is there just a 2 string? Man, I swear. Make. Dag nabbit, did I just spend 5 minutes on that? Well, 10 minutes? 20 minutes? I don't know how long I spent on that. Ah, crap. Okay, that's okay. Make that. Stack Overflow questions. DuckDuckGo. Open link. What do we have? Is people doesn't convert? Let me see what happens if I just run this. Where are we? Euclid. Okay, it works. Great. Okay, so let's put these guys somewhere. I want to put them... No, you didn't miss much. I'm still just doing string. Thanks, Roxtonro. Appreciate it. Okay, so let's do -5 or something like that. Man, my eye is killing me. Okay, let's do -5. Let's do -4. Let's do -5. Yeah, something like this. Make that. Okay, and let's do Euclid. Okay. Oh, that's probably correct. Yeah, let's see what happens. So now I'm going to do toString up here. And let's do plus std toString. Just grab this guy. And let's do element1. Go here, make that. And then we got to move things around, do some things, but we're mostly there. So Euclid. Okay. So here's the part that I'm going to have trouble with. What I'd like to be able to do is have people enter their own text here. If that makes sense. So like I want them to be able to say, hey, I want to do 1024, enter 1152. So that's going to be a little bit hard. But right now if we do the subtraction-based method, we do get this guy working the way you want, in a way. So we have that method, then we also have... Now here's the problem. If I run the modulus-based method, oh, it doesn't destroy the text. Great, the text must be stored elsewhere. So then we're pretty much set. Yep, I think all we need to do now is kind of make it look pretty, which is fine. We do have a clear, see. So we can clear it. We can run it with the subtraction-based method. We can run it with the modulus-based method. So it should be okay. And then the last thing I need to do is say, once this guy is done running, yeah. SDL is an event. Oh yeah, this is something that we need to do next. So that's what we'll work on. I think what I'm going to do is go ahead and get all of the text and stuff aligned appropriately, and then we can go from there. So let me get a quick sip of water, and then we can go from there. Okay. So I'm going to make this text a little bit smaller down here. So let's do that. So we're going to change the text size here. And I think this 1.0 is text size, so let's make it half the size. 0.5. And let's go here. Yeah, it should be. Yeah, so I'm looking at something like this. Okay. We'll get back to that in just a second. So then we're going to drop this guy down. So no longer 0.9. Let's do 0.99. Make... Yeah, well done. We're not there yet. Make that. We haven't even done the hard part. So we'll see how this goes. So we'll do Cyviel Euclid. Yes, subtraction-based method, modulus-based method. That looks great. Okay, so now let's pop these guys down a little bit. So I want, I'm going to want to do, how do I want to do this? I think what I want to do is say we have this guy at negative 0.75, and I just want Euclidean algorithm here, and that should put it in the middle. Then I want this guy to be at negative, not negative 0.1, but instead negative 0.5. And then I want to move these guys to be at negative 6. And negative, I did 6 times. And negative 7. Like that. Yeah, that's okay. Don't worry about it. We'll be back tomorrow. Tomorrow we will probably be working on the Arcane algorithm archive once again. And so we'll be writing up the Euclidean algorithm, stuff like that. So, wait, what did I miss? SQL text event input. Open link. Oh, is this? Yeah, these are both the same things. Segmentation fault. Yep, that's exactly what we expect. So negative 75. Oh, I want negative 25. Make that. Make that. Okay, let's see where everything is aligned. So we'll do Euclid. Oh, that's okay. What I need to do is find a way to center things. I'm not really sure the best way to do that. Yeah, so we're going to have to figure that one out in a bit. No core dumps. Step 2, call the publisher. Let's drop it a little bit further back. So let's do negative 3. Make that. Okay. And then we're going to do Euclid here. That looks pretty good, I think. We might want negative 4 or something like that. So then we want to do these guys, and let's put them all at a similar location. So let's do negative 2.5. Okay. Make that. And let's go to Cyviel Euclid. Yeah, and now all I want to do is move some things around just a little bit, but we're mostly there. So let's go here and let's do, drop this back to 3.5. Sorry about this, this is just me kind of finagling the text. You forgot an existential crisis in between? Totally fair. Dang it, this is going to be in between those guys. So 2.5. And then we're going to do Cyviel Euclid. Something like that looks okay, I think. Now let's drop everything down by a couple points so that it's all on the appropriate line. So we're going to change this to negative 6. Change this to negative 7.5. And this guy down to negative, let's see, 6, 7.5, 8, 9. 9. Make that. Let's see what this looks like. Coding in. Yeah, you did. It's okay though. Euclid. Yeah, I'm gonna have to move everything up by 0.5 and then we'll be good. So let's do 8.5, 7, 5.5. Make that. And then we'll drop the line down a little bit. Euclid. Yep, okay. So let's drop the line down. And then we should be good to go. So let's pop this. Let's see, the line we want position 1 to be that, but we want the Y position to be negative 5, 0.5. Paste it again down here, there. Make that. And now the last thing we want to do is go into VI source, aux functions, and let me check this. So we'll do Euclid. Ah, dang it, it needs to be just a little bit higher. Okay, that's okay. So let's go into VI source distributions. Pop down here, and let's just put it at negative 0.45. And let's see what that looks like. Okay, Cyviel Euclid. Good, okay, so now this is like kind of the base that we're going to be working with, and then up here is going to be the actual algorithm running. I'm happy with that. So let's go into VI source aux functions, and now what we want to do is clear, and let's change the position here to negative 0.45. There. Make. And then the last thing I need to do is when we are running the Euclid subtraction and stuff like this, we have to make the lines draw at the appropriate spot. So what I want to do then is, let me see. Yeah, I think this will be okay. So let's go in here. Right now they're drawing from 0, but we actually want them to draw from negative 0.45. And we want them to draw from 2 there. So then from 0.45. And let's go here and make that. And then let's see what happens when we run the subtraction-based method. And it should work okay, I think. So we're going to run SciVL Euclid, and let's run the subtraction-based method. Great, okay. This looks okay. Again, I don't like the fact that we have blue over white down here. That's something that we need to work on, but rest of it's okay. Okay, good. So now what I want to do is, I could bump this up a few pixels. It's okay. Let's move that also for the modulus-based method here. So we're going to do 0.45. I know this is not very, like, if we break something, it's broken. Okay, go over here and make that. And now all we need to do is have the ability to increase and decrease the values at will. So let's do modulus-based method. Let's do subtraction-based method. Okay, now what I might do for now is do what I did with the FFT algorithm. So we have something working, and then we'll worry about text input after that. Because honestly, I'm a little bit worried about the text input. Also, we should probably make it so somewhere on screen it displays the greatest common divisor. Somewhere. Maybe we should do that in the upper right hand corner up here. Yeah, I'm not sure. I'm not sure the best way to do this. If we break something is broken. Yeah, I'm sorry. My quotes are not great today. I'm really tired. That just sounds way too logical. I'm sorry, guys. I'm sorry. I'm really tired. I don't know. For some reason today, is it raining outside? Oh, it's totally raining outside. Ugh. Oh, that's great. I like rain. I am all over the place. No, today I slept in until like 4:45 or something like that. I haven't slept in that late for a long time. And so, like, I don't know. It's just been really off. I've really been off of it today. Like, this whole time I'm not cognizant of what I'm doing. I'm just kind of working, you know? Which is sometimes good, sometimes bad. I guess for today, it's not so bad. Apparently whether or not it's raining affects his quotation ability. Yeah, no, it affects my ability to think. Like, everything just is just out. Anyway, regardless, let me try to finish this. Let's do it. Okay, so now what we want is the ability to add in, like, a box. So let's go to the Fourier example. Let me show you what I mean. So I do S, and let's do Fourier. So here we have a box that kind of wraps around these guys like this. We want something similar here. So let's do that. It's wet outside. Okay, so let's see. What do we have for the boxes? Good weather quotes are inspiration. Yes. That's how this works. Okay, so let's see. What do we have for the box? Let me just look up for box. I'm sure we have it somewhere. Box size. Reserved children. Box size. Oh, I'm not in the right file. Yeah, source distributions. Let's go down to box, because I'm sure I called it box. Yep, that's what I called it, because I'm great. Okay. So here's the box around the text for our current factor that we are using. Great. Okay, so we have the box color, create line, line box, box color. Looks good to me. Let's just look this up. And let's pop down here. And let's go ahead and push everything back and just do this. Okay. So this will be starting at negative 0.7, but our text is at negative 0. Oh, let me just see where this is. Let's make this. His tongue slips on the wet floor. What? You're okay. Euclid. Yes, the box is too high, obviously. So let's drop it down a little bit. So we want to drop it by negative... Wait, positive 0.7. Oh, these are in X. So negative 4, negative 3. So we want this to be negative... I want to say negative 6.5. Negative 4. 4, 5. Oh, okay, interesting. So we want... I should not have erased those because I don't know the relative distance between these guys anymore. So let's look up box again. Okay, what do we have here? 4, 3, 3, 4, 5, 4, 5, 4. Okay, so this means we want off by 0.1, off by 0.5, 1, 5. Screw it, I'm copying this again, and I'm putting it down there, and we're just going to do this. So here, G, paste, because I just can't remember what I'm doing with my life right now. So let's do that, and let's change this to negative 0.7. So 7, 6, 6, and then 7, 7, 7. Make this. Let's see where the box is. Uses VI. Euclid. Oh, the box is exactly where we wanted to be. Fantastic. Great. All right. That was sheer luck. Okay. So now what we want to do is make it so we can move this box up and down, which I think we've already done before. So let me go to select text with VI. I'm really, really sorry. Okay. So let's see, what do we want? We want for your key or something like that. We should have like an up, down, left, right or something like this. Let's just grab these guys. Up, down, left, right. Great. I'm sorry, Buttercake. Edlin Few. Okay. What am I doing with my life? Let's do Euclid key. Great. SMC. Paste. Great. Okay. Euclid here. Left. We want to do... Par.factors. I have a par.factors? Huh. Wow. That would be useful, wouldn't it? Yeah, maybe I should use that. Okay, well that's useful to know. Okay. I'm going to do plus equals 1. 1. Nah, it's okay. We'll do what we have right now. So we'll do par.imap of element. Oh. Let's say selected element. Ah, this is such a pain. Let's see. What do we have? Yeah, let's do par.factors. Of par.current factor. I think that's the thing. Update FFT. We don't need to do that. We don't need to do that. We should just be able to move up and down, and we should be okay. So then we want SDLK down. Yes, par.current factor plus 1. And we want less than 1. And up here we want, yep, that's okay, minus 1. Translation. Par.shapes.size minus 3. Move shape. Update FFT, we don't need these guys. Oh, that's the translation of the box. That's okay. Par.shapes.size minus 3. Move shape. Oh, this should be the shape or the box position. Okay. So in this case it's going to be 2. Or 1. That's probably it, just 1. Great. 1. Alright. See. So now we should have something that goes up and down. Let me see, what do we have here? Product factors, product current factor. What happens if we just write this and run it? And we do Euclid. Oh, look at that. The box is moving up and down. That's fantastic. Okay, great. So let's change how this guy moves up and down. Instead of negative 0.2, let's do 0.15 maybe. Make that. Oh man, this is great. Euclid. Oh great, okay. Fantastic. So now we just have to change everything so we use par.factors, and this should be okay. So now what we want to do is Element 1 and element 2, I don't think we want to do that. Instead, we want par.factors 1 and par.factors 2. So we're going to say par.factors factors.pushback. And let's do 128 times 8, just for a base number. I'm sorry, guys. Paste, and let's do 9. And then we want to say par.current factor is going to be equal to 0. Great. Now what I need to do is remove these guys. There. Did you first write an editor, write that other editor in? That's wonderful. What editor did you write the assembler code? Notepad.exe. Ah, Notepad. Good old Notepad. Still easier. Roxanro. What did I do, Roxanro? My health cover. Wait, my health cover won't cover that? I'm missing a lot here. Who mentioned Edlin? And we're back to editor wars. I think about how hard all of this would be with Edlin. I can't. My health won't cover that. Ah, I see it. I see it now. Never use that. After that, I wrote my own text editor in pure assembler. Yep. In what editor did you write the assembler code? Notepad.exe. Copycon text edit. Okay. So now let's look for element 1. Yep. So here we want to do par.factors. Euclid mod. Oh, factors. And we want to do par.current factor. Oh, let's just do 0 and let's do 1, because I think that's what we actually want here. Par.factors of 1. 1. And let's pop down here. Oh, I probably didn't need to do that. Par.factors of 0 and par.factors of 1. Of 1. Great. Okay, so did we use element? Oh, I did. I used it all over. Oh, no, but that's okay. So we do want par factors of 0. But we want to change that to an int. So let's do par factors of 0. And let's do par.factors of 1. Of 1. Okay. And let's see, where else did I do this? Element 1, 2. Good. Make that. Let's see what happens if we run Euclid. Okay. Okay, but we're able to increase the number here. That's great. And we're able to do the same thing here. And if we run subtraction-based method, good. Okay, so the decimal points at the bottom aren't particularly great, but that is okay. We'll get there as we get there. So now what we need to do next is change these guys to factors of 1. So let's change this to an int. I think that will solve that problem. Make that. And then the last thing I need to do is modify. Yep, great, fantastic. Okay, so now the last thing I need to do is go down to key. And let's see, S, C. And change these guys so they have the if is down around it. So we're going to do if is down here. And we're also going to do it here. And we're going to do a dot here and say if is down here. 1 second. Is down there, and then there, 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 there. Make that. And we should be able to. Hey friends, what's up? How have you been? Euclid. Oh wait, why did it go? What? I press left and it immediately goes back down. I'm not exactly sure why. Okay, well I can modify this number all I want. That's pretty good. What happens if we just run subtraction-based method here? Ah, okay. Seems to me like there are a lot of values. Yep. Okay. Yep. Pretty good. I'm actually not sure what's happening here at all. Yeah, I'm not really sure. Okay, we're gonna have to figure that one out. Okay. Had a lot of schoolwork. Haven't had enough free time to watch the streams for ages. Don't worry about it, man. I've been in and out for streaming anyway, so you haven't missed much of my streams. How much memory are we speaking here? Wait. He used manually replace the HDD so that the cosmic rays or whatever hit on the right spot and flip the right bits to create a runnable program. That is wonderful. Tesm actually had a built-in editor, but it was kind of not usable for simple text editing of random things as it didn't fit memory. Yeah, I see. Let me see. I used to work at a mechanical engineering company. They write software that goes directly onto the chips in their machines. So they would regularly hear stuff like, "Hey, come here. I managed to save another 15 bytes." A funny thing that I did, that it did have VGA. I bet you I didn't break it. I did break it. Dagnabbit. Right. And left both go down. Oh, it's probably because I need to do... What if I do if is down in here? Yeah, I'm actually not sure. I'm not sure why it would go down after this. So let's just do if is down here. And let's also do it here. There and here. Add some spaces in here. And some in here. And let's see what happens if we write this, go over here and make it, and hope it doesn't break. So I go Euclid. Here's the thing, I press right. Oh, good, 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 it's working now. Okay, so everything seems to be working. It's in black and white, that's okay. Let me use the modular space method to see what happens. Okay, so the last thing we need to be able to do is write out the greatest common divisor somewhere. So let's do that. And we also should probably change the... Yeah, so there's a bunch of things we should change. Let's not deal with text input today. Let's get everything else working so that it kind of looks okay, and then we'll go from there. Because, for example, let's run this. I'm fairly certain if we change this to 25, the greatest common divisor between these guys will be like 1 or something like that. So I've got a feeling that... Wait, is it 1? Wait, I have to think here. Yeah, we have to have some way to write the greatest common divisor here somewhere. I'm just not sure where the best place to put that is. What do we have? What would you ever need 256 colors for? Funny thing was that it did have VGA. Oh, interesting. But I only had Hercules monitor. I'm kind of glad that these times are over, but I still hate to waste space for various reasons, including that I hate load times. I mean, even most DOS programs loaded instantly. Nowadays, we have to wait for apps to open. Oh, yeah, fair enough. Okay. So here's one of our methods. Again, I don't think it looks so bad. I think there's a couple of things that we need to fix here, but that's okay. So now let's see if I press... Oh yeah, that's currently a problem, isn't it? Okay, so now let's change the clear. So let's go into VI source and let's do aux functions. Pop down here and let's see, what do we have here? The GCD is 1. Yeah, I'm not sure exactly what to do in that case where the greatest common divisor is 1. So we have to kind of think about that. Okay. So let's do create line here. You could clear. What I was doing before was I was basically destroying. Let me see, how do I put this? I was destroying all of the shapes, so I was just clearing shapes par. But I think what I actually want to do here, instead of clearing the shapes, what I want to do is I want to say, how to do this? We're going to say par.shapes equals, oh, I know what I want to do. I want to say, what do I do? std vector of shapes. Oh, sorry about that. Shape. And then we're going to say elements of size 2. Okay. And then basically what I want to say is this is going to be equal to elements. Yep. And then we can just remove everything else and this should be good to go. So now we'll just say elements of 1 or 0 is going to be equal to par.shapes of 0. And we do the same thing here, and elements of 1. And then this should be exactly what we want. So let's go over here and make that. It's curious that computers are 5 orders of magnitude faster. So that's clear. Good. Seems to work. Subtraction-based method. Great. Modulus-based method. Great. Okay. Everything seems to be working okay. So now what we need to do is figure out some other stuff. Lots of things to figure out here. So firstly, where do we put the greatest common divisor? That's a good question. I think we can put it right here in the upper right-hand corner for the most part. I think that's okay. So let's, or we could put it down here somewhere. It's curious that computers 5 orders of magnitude still somehow slower than back in the day. Let me see, slower to use. Totally agree with you. Yeah, I don't know, it depends. I mean, at least for me, my computers have sped up by a good bit. You know, I know that if you compare my Arch Linux installation on my old crappy laptop that I had versus my machine right now, I mean, it's like night and day. This computer is running much, much faster. Well, it's not like night and day. It's running much faster, but the other one was still quite snappy. I mean, I can still pull up the old laptop and it will work just fine. You know, I have no problems with it. But that's okay. Storage drive is hundreds of megabytes per second read and write speed. Okay, so how about we just go ahead and put the greatest common divisor somewhere on here. So what do we want? We want to do VI source distributions. Dagnabbit, caps lock, all the time. Freaking, there we go, distributions. And now we want to do Euclid function. Okay, so one last string I need to put down. We're gonna have to save the greatest common divisor somewhere. So let's go ahead and do that. So we'll say position text is gonna be in the upper right hand corner. So we'll say let's do 0.75, negative 0.9, 0.0f. Obviously all these guys are floats. So let's do a float here and a float here. And let's grab these guys, yank to yank, paste it here, and we're going to say greatest common divisor is GCD is, let's add a space, and then we'll add the string in just a second. Let's change this to a 1.0. glmvec3. Good. Okay, so see what happens if we do this, make that. Imagine running old software that, wait, I'm missing a good bit. Error 1, fantastic. Position text, that's because I misspelled text. Go over here and make that. And then we'll go back to chat. Just a second, let me make this and then I'll check chat in a bit. So we'll do Euclid. Oh, that's way down there. I did not want it way down there. I wanted it up atop. And also this guy's probably gonna have to be 0.6. Make that. Savula S Euclid, GCD is, it's still probably 0.5. Make that. Euclid, great, okay. So now since we don't have a GCD, is that, I want to do, what do we have here? What do we do? I'm gonna say, we want this guy. Except in this case, it's going to be par.imap of, and I guess we're just going to do GCD. Something like this. Now let's go down to Euclid par, and let's say, since we know the greatest common divisor here, we're going to do par.gcd, imap of GCD is going to be equal to 128. See what happens when we write this and make that. And then, again, I'll check the chat in just a second. 128. That looks pretty good to me. So now the last thing I want to do is say, right quit, go into VI source, aux functions, And then we pop down here and we modify the greatest common divisor when we get here. So Euclid sub. At the end, I think we return A. So what do we have here? We have A and B. Here's the 4. Wait, where's the while loop? Here's the while loop. And so now what we want to do is par.imap of GCD is going to be equal to A, I think. Let me take a look at this real quick. Okay, 1 second. What do we have here? For the subtraction-based method, we return... Oh, well, A is not equal to B. Oh, so A or B would work in that case. So then the modulus-based method up here, let's just go ahead and paste it here. We return A. So let's do par.imap of GCD is going to be equal to A. Make that. Okay, good. Seems to work just fine. So now let's do Euclid. We know the greatest common divisor is 128 for this one. That's okay. So let's drop this by 2, and let's see what happens if we run the subtraction-based method. The greatest common divisor is 2. Great. Okay. So if we change it to 49, greatest common divisor is 1. Great. Okay. This is working okay. I'm okay with that. Okay. What did I miss in chat? You're using Arch Linux? Yeah, that's true. But back then, you could use clock cycles for timing since pipelining hadn't come along. By the way, I use Arch. Oh, good. I find it weird. Okay, maybe this isn't weird, but it seems to me that Arch Linux users tend to come together. Like, it seems like when someone says, hey, I use Arch, like 5 other people are like, oh yeah, I also use Arch, but it's still not the most popular distribution, so I don't know where all the other Linux users are. I just know that for some reason, most of the Linux users I know use Arch. You know what I mean? So I don't know where the bias is there, but I know that that's what typically happens. Up to Pentium MMX, that worked. I'm a noob with Linux. That's okay. We then moved to resource allocation, Pentium assembly. Oh man, I love the interleaved execution. Does that mean you're new to it or you don't use it at all? Pentium was glorious. I use Ubuntu and Debian, and I have for a year now. Oh, you're not a noob then. That's pretty good. Imagine running old software that ran on these 64K machines back in the day on new hardware. Lightning fast. I don't think they'd be any faster, at least perceivably. This axis, of course, etc. The Gathros for how long and how frequently. You need a few kilobytes of RAM, and then you'd have gigabytes left over. Ubuntu for full-time, Debian rarely. For how long? Wait, isn't that what you just said? Did I just read something over again? 1 second. Oh, I see. That's simply. I still have some issues attempting to optimize things for memory. Well, let me see. I use Arch. It's kind of the meme for some Linux communities because they seem to like to mention it. Yeah, so in some sense you could say the Arch are like the Arch users are like the vegans of the Linux world, you know? You'll know if they are an Arch user. On the other hand, I don't know. Arch it's a good distribution. Like, if you like the distribution you're using, I think the fact that everyone says that they like Arch or they use Arch, I think this is good reason. Like, I think people are publicizing it because they like it, you know? I think they're saying that because they like Arch, they're willing to put their name as an Arch user. You know what I mean? Like, it's good marketing that your users are willing to speak for your product. And especially in Linux, that's very important, you know? On the other hand, I think that a lot of Arch users get overzealous. I think that they tend to look down on people who use other distributions, and I think this is bad. I think that whatever distribution you're using is fine, as long as you can appropriately use your machine and you're happy with your machine. That's what matters most. So if you're happy with Windows, that's great. If you're happy with Mac, that's great. If you're happy with whatever you're happy with, that's great. Just use what you like, be happy with your computer, because in the end, you know, your operating system should not inhibit your work. Your work is the primary thing. Your operating system is the thing that allows you to do your work effectively. I'm thinking about jumping to Arch, but I don't want to risk it. Linux users are the vegans of operating systems, and Arch users are the vegans of Linux users. Could be. I don't know. I think most Linux users are very zealous about the fact that they use Linux, because I don't know. There's actually, if you go to the algorithm archive, let me see, where is it? I'm sure I have it up. There's a bit here. I think getting started. I talk about what got me into computer science to begin with, and I talk about my first Arch install. And it's the thing that really did get me motivated to do any type of programming. You know, like I do this, and then all of a sudden I'm like, man, computer science is cool. Like programming is cool. It's the thing that gets you into hobby programming. You know, is your first step or first foot in the door, so to speak. And it's nice. You know, it's one of those things that really does motivate me to do new things. Okay, so now let's see what happens if we do Euclid here. And we do, I tend to be quite religious about things. They're very passionate, not in a bad way though. It could be in a bad way though. Like I'm not here to defend the Linux community. I use Linux. I'm very fond of Linux, but I'm not here to pretend that they're somehow better than anyone else. You know. I think the biggest problem with the Linux community right now is gaming. You know, I think that a lot of the Linux community feels like if we had gaming on Linux, that all of a sudden all of the problems would be solved. You know, that all of a sudden the world would be a better place and Linux would be the most popular operating system. And I just don't think that's going to be the case. The problem is, people don't know how to use Linux, and the community needs to be more open. You know, I got into computer science because I was bored on a holiday. Been there, done that. I know exactly that feeling. 25. Greatest common divisor should be 1. Okay, let's take a look at the subtraction-based method. Okay. So how does the subtraction-based method work? At the end, we return A in the subtraction. No, we return A or B because they're both the same. So if A equals B, oh, I see. So the next time A and B are equal to 0 because they're the same guy. If A is not equal to B, oh, wait a minute. Yeah, I'm not exactly sure what's happening here, if I'm being honest. How this is telling us that it's equal to 1. That's something we have to think about. Let me do the modulus-based method. Yeah, this is something I'm going to have to think about. The best way to visualize this. We know the greatest common divisor is 1. That's fine. The modulus method. Okay, so the modulus method, what we're doing here, is we're going through and we're saying that we're continually doing A mod B. And A mod B will divide A by B, right? And if A is greater than B, or B is greater than A, then we just switch them around. Let me increase this. So it is 152. So here the greatest common divisor should be, yeah, 152. Okay, so what just happened here? We did the modulus of A and B, right? And the answer to that should have been 0. So T equals B. Let me think. So what did we actually output? We output 1152 twice. Okay. So we output 1152 twice. And that's going to be this value here. We do the modulus of these guys. So T is going to be equal to 11. Here, let me write this out. And let's see what we do. What do we have here? Gibbs boy. 6 years uptime. Wait, what? Oh, I see what we're missing. 93 wasn't ISDN. I was running 93 when I got my Pentium 133. I got computer science. Yeah. We have gaming on Linux though, not nearly everything, but I run OpenSUSE on my gaming rig, and I only boot up Windows. We don't want to play it on Uplay. What is Uplay? Oh. I know, this should be 0. That's the thing I'm trying to figure out. So I think I need to figure out how to better visualize this right here. That's super important. Okay, so let me think. What's the best way to visualize this? In fact, in some sense, maybe I should have just done this on a chalkboard for the actual video. No, this doesn't make sense, because if we do a large value like we're doing here, then it does make sense that we will One second. I'm sorry about the yawn. Again, I apologize. Woke up late this morning. Super groggy. Yeah. 1152 mod 1152 equals 0 mod 1152. Just whine about how you play. Yeah, but here we're outputting A and B. So A should have been one line, B should have been the other line. Maybe we should appropriately color these numbers so people know which one's which. Like we should say one's blue, one's white. That's okay. We'll get there. We'll get there. I have Ubisoft game on my tablet. It's supposed to have online play, but it doesn't work at all. Sorry. Let me think. So let's see what's happening. I'm just going to open up Zernal, and we'll see how this is going. So we're going to do Zernal here. And let's see. Okay. So there are two different methods. Let's do the modulus-based method here. Nah, don't worry about it. I'm slightly off today anyway. So let's do Zernal here. Modulus method. Mod method. Okay, so again, here's the method. We do while b is not equal to 0, temp is equal to b is equal to a mod b, and a is equal to t. Okay, so let's plug these guys in. So so temp is going to be equal to 1152. B is going to be equal to 0 because it's going to be 1152 over here. Yeah, it's just going to be equal to 0, so we know it's going to be equal to 0. And the next one will be A is going to be equal to 1152, okay? Next iteration is going to be A mod B. Wait, what am I doing here? B equals 0. Okay. So the next one, this is going to be equal to 0. This one's going to be equal to A mod B, which is going to be 1152 mod 0. Oh no, well B is not equal to 0. One second. B is going to be equal to 0. So this means the greatest common divisor is 1152. So what is that last line showing? So then we exit the while loop immediately. What? Let me think. Yes. Let me see. This one about how bad you play is. It is terrible. What is Linux? Oh, it's the theme. Sorry. Wait, what? I'll just move on. The theme of today has been being distracted. That's fine. Could you also label the axes? Here the axes don't really mean anything, so I understand it's going to be a little bit weird. So let's just do the subtraction-based method. Here's the idea, guys, right? So what we have is two values, A and B, that we're iterating through. A is going to be the blue one, B is going to be the white one. So here A and B are equal because we've subtracted out a particular value, right? And that value is here. So here A and B is equal. Wait a minute. Wait. Okay. What we did is we said A is blue, B is this guy. Right, so B is white. So then we did put the scale. Yeah, it's gonna be super hard. Gosh, that's gonna be hard. Yeah, I can try that in a bit. But we have the scale. That's what this guy is, right? I mean, so the scale is the maximum value here. So the scale is 1152. You know? Alright, I can try to put the scales in a bit. That's going to be a bit of a pain. But we'll see. I'll remember not to mention Edlin next time. Oh, fair enough. Let me see if I can get the visualization working, and then I'll worry about putting in the scale bars and stuff like that. I'm not really happy with the plot that we have now anyway. So, the min is 0. Yeah, I guess so. I'm actually not sure what the min is. So, it's probably 0. The last bar in that case should have been 128. But that's the thing, I don't think it was. So we run subtraction here. So here we have basically 128 times 8 and 128 times 9. So here is 128, right? All of these guys here, this means that yeah, I'm not really sure what the deal is. I'm not sure what's happening. That's the thing I need to figure out. So I think I think we might need to figure that one out. We are getting the correct greatest common divisor. So we know the algorithm's working. Max val, else max val is equal to b. I'm surprised no one mentioned the lack of syntax coloring today. Yeah, that's because everyone who came in that noticed I wasn't using syntax highlighting probably just left. Okay. So let me see. So we push back A and B. Oh, I know one problem. Okay, so here we have these guys. If A is greater than B, we push back A and then B. Okay, maybe what I should do... Okay, I have an idea of something that I need to do anyway. So... Okay, here's the idea, right? So we do page, new page before. We have the two different values. Here we have... Let's just do the subtraction. Oh my gosh, that did not work out. Let's just draw a single straight line. Okay, value 1, and then value 2, right? So they're off by this amount here, right? So what we do then is we find the amount that they're off by, right? And then we subtract that amount from the larger amount here. Wait, let me think. So if A is not equal to B, then we say A is going to be equal to A minus B, or B is equal to B minus A. So if A is greater than B, which in this case it is, we say A is equal to A minus B. So we subtract this guy from this guy. So we move these guys about, and we're left with, in the next iteration, we are left with B being this large guy, and A being this small guy, right? And then the next iteration, we say, okay, well then, we have this much different here between these guys. Okay, so then we say B is greater than A. So the next time step we're going to do B minus A. Yep, so then we're going to subtract the small amount. So that's exactly what's happening then. So then we subtract this small amount here, so then B drops a little bit, so then we're left with this, and then drops a little bit again, so then we're left with this, and then drops a little bit again, so then we're left with that, or something like that. Yeah, okay, so that's what's happening. So basically what's happening then is we're slowly converging onto the greatest common divisor. However, the one thing I don't like, I think this is correct. We slowly subtract, we keep subtracting out, and I think that's correct. So I think what we're showing here is correct if we do the subtraction-based method. We see that it's dropping by a particular value every time. However, I don't like the fact that it stops here. I think that's a little bit weird. That's when A equals B, and it should be that this is 128, but it's clearly not 128. Because 128 should be this amount here. So I'm not sure why it stops there. Actually, wait, I might know why it stops there. Let me see. The values here are going to be drawn... I think I know why it stops there, actually. Okay, so we're drawing a line between these guys. However, let me think. Negative 0.45. Is this a subtraction? That's the modulus-based method. Let's go to the subtraction-based method down here. 0.45. Okay, so these guys are being drawn from negative 0.45 on the screen up to positive 0.45 or up to the very top, right? Yeah, I'll have to leave you guys. All right, see you, Buttercake. Thanks for coming in. Appreciate it. See you tomorrow. Tomorrow we'll probably take a step back and do the writing for this particular visualization on the algorithm archive, and then we'll go from there. Okay, I'm gonna have to do a lot, I think, to get this visualization to work better. So I have some ideas of how I want to do this. But let's see if we can just get what we have right now working, then I'll commit that. And then I think I'll call it for the day. And then we'll come back and finish the visualization, probably not tomorrow, but the day after that. So I apologize for taking so long with this visualization. I didn't expect for it to take this long, but that's how it goes sometimes. So we will see. Okay, so divisors of I plus 1. Yep, this should be okay. And we're going from negative 0.45 to 0, and it's going up to that value there, which means what we actually need to do is subtract out 0.45 here, 0.45 there. So I'm going to pop this down to the next line, and we're going to have to multiply this. Divisors divided by max val. So let's do multiply this by some value, which is going to be as high as they can go. So it's going to be times the entire length. So it should be 1.45 times this. And we do the same thing down here. So now let's do 1.45 times this and subtract out 0.45. Go over here, make that. And I think if we do Euclid, we do the subtraction-based method, it should... Yeah, okay, it's going to drop all the way down now. Good. Okay, I believe that. This is 128. Good. So let's do the same for the modulus-based function. And then we can worry about making this more... Well, just making this better in just a bit. So let's go here and let's modify this. Okay, so 1.45 times, and then subtract out 0.45. There, and we're also going to do the same thing here. So let's just subtract it out now, and then pop it down here. So we'll do 1.45 times. Go over here and make that. Okay. Euclid, modulus-based method. We should still be able to find 128 again. Yeah, okay. Fine, 128 and 1, that's okay. Okay, so now the question is, how do we appropriately represent these guys in a different way? I think the best way is to do what I did over here and have 2 different bars. So actually 3 bars. We're going to have 3 bars here total. We're going to have A, B, and then A again back here. So what I want is to draw 2 bars in white and 1 bar in the background in blue. And the background bar in blue will be the difference here. And that should allow us to more easily represent these guys. So let's see, we're going to want to push back 3 values every time. So this is going to be, well, let's do the subtraction-based method first, see how this works. So first I'm going to do get status, and let's do get add source aux functions and source distributions. I was looking for a reason to get distracted. That's fair enough. So let's do get commit dash m, adding, let's see, new text and visualization. Details? I'm not sure. So let's do get push. 1 second, origin beta. I think we're on the beta branch right now. Good. Okay, so that should be good to go. So now we have to change the visualization method, and we should be good there. But I think, let me see. So we have the divisors. We're going to push back A and B, and we want 3 different values. So, okay, I always want to push back A and then B. Let me think. Worst case for mod-based method is consecutive Fibonacci numbers may be helpful for actually getting a decently sized graph. Yeah, could be. So that's something that we might want to look at. Let me do... Let me think about this actually on my own time. So I think I'm going to go ahead and close stream for now. Again, tomorrow we'll come back and we will do... we'll probably finish up the visualization then, and we will run the visualization a few times to get the appropriate values for... to get the appropriate visualization for the algorithm archive. I don't know, I can't talk today. I apologize for that. So I think I'm going to go ahead and close stream for now. I will see you guys tomorrow for the next episode of Simuleos, when we hopefully finish up the visualization, start working on the algorithm archive stuff, maybe even add in text input. We'll see how things go. I think I'm a little bit too hopeful to get everything in, but I think that's enough to go for today. I need to figure out the best way to do the visualization, so I have to kind of think about this a little bit on my own time. I do definitely need to add in axes, like you were saying, Labassel, and things like that. I just haven't decided the best way to go about adding all of this stuff. So I need to think about that before continuing. Anyway, guys, thanks so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we continue working on this, hopefully finishing it up, because again, this algorithm is quite straightforward. I feel like all of you guys have already implemented it on your own, so it should be rather quick. Outside of that, before leaving, I wanted to ask one quick question. And that is that this weekend we'll be doing the Euclidean algorithm like we're doing right now. But next weekend I was thinking about doing a video on how to use like Git, version control and stuff like this, and basically suggesting to people or showing people how to like submit pull requests and things like this on my YouTube channel. So this means next week I don't really have an algorithm that we're going through, but I think what I'm going to do is I'm going to ask and do an algorithm anyway, just to go ahead and get ahead. But I think this is going to be an algorithm of my choice, so I think next week we'll be doing like maybe Barnes Hut or something like this, a galaxy simulator. So let me know if you have any ideas for something you want to do. And I'll go ahead and add that to the list. I usually put up a Twitter poll, but I kind of wanted to get your guys' opinion separately as people who just watch Simuleos, so kind of something a little bit more unique to this channel instead of YouTube. So that's kind of the idea there. Let me know if you have any suggestions, just via chat or something like that, and we can go from there. Outside of that, I do want to point out that I'm actually quite happy with how the algorithm archive is shaping up. I realize, yeah, we don't really have that much right now, right? We only really have relay integration. I think I have something on Euler methods, Gaussian elimination, Thomas algorithm, tree traversal, Taylor series, FFT. But I mean, we're getting there, right? So that right there is, let's see, 1, 2, 3, 4, 5, 6 different algorithms. You know, that's not bad. And a lot of these we haven't made videos on, so I haven't really asked for sample code. That's quite good. Quite happy with it so far. Anyway, that's it for today. Sorry again for rambling, but I will see you guys next time. Let me know if there's something you want me to cover, and I will do my best to cover it in the near future. Thanks guys for coming in, and I will see you next time. Bye guys.